Hello, everybody. So, few words about me. So, I'm a geographer, I'm a climatologist, I'm a meteorologist, I'm a GIS man. I like Python. Thank you. And that's the intro. And okay, so today I would like to take you on the something like the adventure with testing data. Probably you tested data in your normal current job or in the past. And I would like to focus on expected values in testing data. And there is two approaches, golden and generic. Later on, I will explain these mysterious terms for you, and we will try to figure out which one is better, which one we can apply to our project. Okay, so this is introduction slide about data lifecycle. I'm an author, so you can agree with it or not, and I will agree with you if you not agree with me, because this is very simple data lifecycle. But probably it looks like this. So we gather data from the world. We can measure the world. We can do the survey. Many methods to collect the data, right? And we need to store the data somewhere, yeah? We got many databases and many format of the files. So we've got a lot of opportunities, right? And what we are doing next, we are transforming the data. We are converting the data because we need to prepare the output, the result, which we can analyze. Yeah, we can analyze it, interpret the data. We can make a graphs, make a diagrams, maps, and at last we can share this data to the other people, and we can use it in our normal work. And today I would like to focus on the one of the phase. Oh, sorry, transforming. Here, absolutely here, we can do many mistakes because many things can happen during this kind of phase. Yeah, we can corrupt data exactly here, mostly. All right, so we've got in testing data, we've got some players, some objects. Probably these guys you know very well. Requirements in testing data. What is it? This is a logic. This is the algorithm. How we can convert our data. So as you can see, the very example. Let's convert from the source. For example, we've got a column from the source to another column and convert in that way. We can reformat. For example, data type date. We can reformat date to another format, right? We can calculate on some algorithm from the source to the output. And this kind of requirement, I don't like it. I like the quasi-code requirements in that kind of format because it's better for the developer, for the tester, to put it to the dev system or test system. Okay, I think I will also mention it later. And test set. Test set, crucial thing. We need to, this is the input set, which we will input to the dev system. And it's based on requirements, right? And cover all possibilities, mostly all. In perfect world, we would like to cover every kind of requirements. It is possible sometimes. Okay, we can generate this test data set manually. Maybe not generate, just create manually and generate automatically. Yeah. So we got two methods creating that. Actual, we know what is actual. This is a result from our developer system, which based on this requirement, and we feed this developer system but by test set and expected. This guy is important for us. Yes, it is prepared by tester, of course, based on the same requirements, and link with test set. And here we've got different method to prepare that. And of course, test assertion, yeah? So we compare the actual and expected together, yeah? That's fine, actual versus expected. And when is the difference between these values? We can say that we've got this beautiful creature, but not always, because sometimes, for example, we as testers can do some mistakes. Let's go through the 4 scenarios. So understanding requirements and implementing in the developer and the testing system. So let's imagine the first scenario. So we've got actual prepared by developer, and this is okay, yeah. So the interpretation of requirements was okay, and developer prepared it well. Tester have done exactly the same. So no bug, test passed, everything is all right. The classic situation, developer understand the requirements in a bad way and made the mistake. So, and we of course we as a tester preparing our expected very well. Classic creature detected. Yes, this situation is. Yeah, this is a very high possibility to happen with this kind of situation. So actual is okay, and we as a tester made the mistake. False alarm, it's not a bug. And the nightmare for the system. The nightmare. But under one condition, only one, it is almost not possible to do that in testing data. Let's imagine that we as a testers made exactly the same mistake as developer. I don't know that it's possible, but it is. Yeah. So the creature said bye to us. Yeah. Okay. So that slide was important to understand a later slide. So can we test data manually? Yes, we can. I will try to based on very simple example. So we've got our requirements. So let's imagine that we've got a letter. It's a column name, and this is the source, and we've got target code. And this is our requirements. I like this requirement analysis. This is this quasi code. It's not even quasi. It's a Python. As a developer, I just take it and put to my dev system. Perfect situation. No space for interpretation. Everything is clear. We cannot make a mistake as a developer, and tester also, right? Everything is clear here. And yes, and we based on that example, so we just map the A to the 1, B to 2, C to 3, and so on. And we prepare on this example the test set. Look on that. We've got a letter, our source column, A, B, C, D, and E for now, for example, yeah? So we prepared the test set manually, yeah, of course. And what we are doing, we are just run the developer system and convert the data from the letter column to the code column, and the result of is actual. So this is the result from the system. 1, 2, 3, 4, now. Perfect. I believe it's okay. And this is me. I will test it manually, totally manually. So I just take the requirements, I just take my test set, and I created in my mind the expected. And I just compare this expected with this actual. And in my test management system, I click, yes, 1 is 1, okay. Yes, 2, we've got also 2. Yeah, everything is okay. I click mark passed. Yes, we can do that. And look out, just close your eyes. But this is the real world. I love XML's structure. It's not a flat. I can look on it and do exactly with this cup of coffee or many cup of coffees, this comparison between values. And I'm a geographer, so I'm working with geospatial data. And I've got this cloud of points. Look at my eyes. Okay. Testing data automatically. I think that it's a better solution because data is very cool to automate these comparisons. So the first approach, golden expected, requirements exactly the same. Test set is exactly the same. Dash system, we just run on this dash set. We've got the target code values. And actually, we've got the two sub approaches to prepare expected. We can do it manually. This object, yeah, this column could be a CSV, why not, file. And we just, look on it and we prepare this file, 1, 2, 3, 4, and now. Yes, with cup of coffee, of course. And we can do it better, but it's not still perfect. We can just copy the actual and review this data and correct if we need to correct it, yeah, this data. And on that stage, we can detect the bugs, yeah, when we review it and correct it. But it's not a official test. It's only a review, right, and correct it. And the official test is here, assertion. So we've got test cases automated. And this is golden expected. So as you can see, the golden expected we are preparing manually based on developer system results. And it could be not so gold. Could be because it's still manual work. All right, so we prepare it. That was during developing our system and test framework. And now we just want to release another version. So we got a request from the client that we need to add some new conditions. So another is Z to 0. Let's map it. So we prepared a set or never generated via a script. We've got Z at the end, and we run the system. So of course, in actual, we've got 0. Everything is okay, and we need to update our expected. So we can do it via script. We can do that, yeah, but it's not so easy, yeah. That's only very simple example to do that, yeah. We've got much more complicated data. Oh, sorry. So yes, so this is sorry. Okay. So the next approach is generic expected. So exactly everything is exactly the same, and we've got this. So in this approach, we just reproduce the logic as in developer system. We create something like the other mechanism in another technology, but maybe it's maintainable, yeah, this mechanism. But it's not so pretty as, for example, dev system, the code, I mean, yeah. It's not there is not a sonar or monitoring tool is not run on our test framework, but it's reproducing this kind of logic in requirements. So we just take this Python code and put to our test framework. We've got another system which is doing exactly the same, and we've got unit test. So what we are doing, we just take this all possibilities A, B, C as an input, and manually put 1, 2, 3, 4, parameterize our tests, and we've got unit test. We are doing very similar as a developer. This is very similar work. We've got pull requests with our tester in our tester team. They just review our code. We are programmers actually in that approach, right? And we are generating our expected totally. It's totally automated. Yeah. And of course, what we've got our assertions. And in that, when we release new version, what we have, we need to, of course, maintain this whole system, actually, right? So we need to update this kind of requirements or this kind of mapping, and we need to update also our unit test. Yeah, so that's why there are these red eyes, and this is this is time-consuming work, right? And yes, so this is to summarize it. Yeah, so golden expected, pros and cons: easy and fast to prepare, hard to maintain, right? Dependent on dev system, which is a big minus, because the test shouldn't be dependent, and not fully reliable because we are doing a lot of work manually. On the other hand, we got generic expected. It's time consuming. We need to know something about programming, right? But later on, it's easy to maintain. It's totally independent. And if we apply the unit test, as I showed, it's fully reliable. Yeah. And that's it. Thanks.